So this is a review of the work we did during the previous week on inequalities. So before we go too far, let's review our signs. We have a less than sign that looks like that. So this is less than. This is greater than or more than. Okay, and if we add an equal sign, this would be less than or equal to. And if you add an equal sign here, that would be greater than or equals to. And the other sign that you saw was not equals. Okay, so the first question here, we need to write the symbolic form of an inequality in 2 words. Okay, so in the first one, we can see we've got 2 is, this is greater than -6. So we would write 2 is greater than or more than, up to you, is greater than -6. Like that. In question B, we have -23 is less than or equal to -7. So -23 is less than or equal to -7. So -7. And the last one, we can see that -3 is not equal to 3. So -3 is not equal to 3 for that first question. So in question 2 here, we need to write the number sentences that can be represented by the given number lines. So there's probably more than one way to do these. So as long as I can follow your writing, then it will be okay. So here we can see we've got -9, and it looks like all numbers that are greater than -9. Notice there's an arrow. So this will continue to positive infinity in that direction. It doesn't actually stop anywhere. That's an arrowhead. So here we've got all numbers greater than or equal to -9. So that would work. So all numbers that are greater than or equal to -9. Okay, use all words, don't use digits for that. Okay, and B, we've got from -3 until 8. So one way I would write that, I would say all numbers we could say between -3 and 8 inclusive. I use this word inclusive because I'm including the last number and the first number. So I use the word inclusive for that. So think of that as being equivalent to including the end numbers. Okay, if you don't include them, we would use the word exclusive. So if you have this situation, you could say between 1 and 6, but use the word exclusive, which is equivalent to excluding the n numbers. So this is a way that we can be precise in our terminology. If you only use the word between, we're not quite clear whether we're including the n numbers or not. Or if you use the word from 1 to 6, that's also not clear about whether we're including the n numbers. So I would suggest you use the words exclusive and inclusive here when you do these questions that are including the n numbers or not including the n numbers. So in question C, we can write this one a little bit differently. We could say all numbers, or we could say 7, negative 7. So let's write that as negative 7, because that's obviously one of the solutions, negative 7. And all numbers greater than negative 7, but less than 2. So that would work. We can do it that way. Okay, so let's look at question 3. So draw the number lines representing the numbers shown below. So the number line's already drawn, but we just need to show the solution. So all numbers less than or equal to negative 6. Well, negative 6 is here. And we're including negative 6 equal to. So we use a solid dot. And we'll go back into the negative direction there. So when we're doing these questions, if you've got less than or equal to, or more than or equal to, we would use these symbols here. We use a solid dot to show we're including the n numbers. If you're not including the n numbers, we use an open circle as well. Some textbooks will use a square bracket like this when you include the numbers, and another textbook may use a curved bracket, a normal bracket, to show we're not including the numbers. But you haven't seen those just yet. You may see those later. So in question B, all numbers less than negative 4. So less than means we're not including negative 4. So less than negative 4 will go in that direction and put an arrowhead on it. So don't forget the arrowhead so I know where you're stopping or not stopping. So question C, 3 or more than 3, but less than 9. So 3 or more than 3, but less than 9. And we don't include the 9, less than 9. There, we've done that one previously. So let's look at this question. So what we want to do here is check whether this particular number, negative 2, will make this statement true or false, this inequality true or false. So you basically just substitute your number. So we'll put negative 2 into our inequality, and we'll subtract 5, less than or equal to negative 12. And then we compare the left side and the right side to see if this is true or false. So 3 times negative 2 is negative 6, negative 5, less than or equal to negative 12. Negative 6 minus 5 is negative 11, which is less than or equal to negative 12. And is this true or false? This is going to be false, isn't it? Because actually negative 11 is greater than negative 12. So this is false. This one here. So in question 2, or 4b, we do it the same way. We'll substitute -3 into everywhere where you see x. So let's put that in. We're going to have -3 times -3 plus 4 less than -2, 3 minus -3, like that. So then we'll multiply this side. We'll get 9 plus 4 less than -2 times, oh, let's actually just do that bracket first. So -2, 3 minus -3 will be 6. And then we'll add those numbers there. So 9 plus 4 less than -2 times 6. We'll just write it again. So 9 plus 4, that's 13, less than -2 times 6, -12. So we can see that 13 is actually greater than -12. So this is also false there. So in question 5, this is a very common thing that you need to do, and that's solving your inequalities. Okay, so we'll just talk about some of the rules as we go along. But remember that these can mostly be done the same way as when you solve equations. So what we should do in question 1 here, we can see we've got a 2x. So to get rid of that 2, we divide both sides by 2. And then we will cancel the 2 there. So we'll end up with x is greater than -8 on 2. So x will be greater than -4. So that's your symbolic form of the solution. And then we put this on the number line. So -4 is here. And then we'll be greater than that number. So just draw an arrow like that. Okay, that's all you need to do. So make sure you put these on the number line in your homework. So in question B, it's a little bit different. So what we're going to do here, we'll divide by -6 as normal, like that. And this will be equal to x. But remember, when we divide by a negative sign or we multiply by a negative, we need to change the direction of the inequality. So here we're dividing by -6. So we're going to need to change this direction to be greater than or equal to. So if it's got an equals part here, also carry the equals as well. And 18 divided by -6 will be -3, like that. So -3 is here, and we include it. And any number greater than -3. Go that way. Let's just tidy that up. So -3, like that. So in question C, a little bit more complicated. We're just adding another term. So what you would do here is you've got a -4. So let's get rid of that first. So let's add 4 to both sides. So we'll have 3x is greater than or equal to -4. Okay, and then we will divide by 3. So we're dividing by a positive number. So the sign is not going to change direction, only when it's negative. So therefore, you'll get x is greater than or equal to -4 on 3. So that's actually the same as -1 1/3. So you can't exactly see -1 1/3 here. So what you should do, get fairly close to where you think it is, about here. Draw your arrow in the correct direction, so greater than. And then I recommend to draw that number here, so -4 on 3, when you do your work, just so we can see exactly what the actual number is, because we can't see it on the actual scale. In question D, we do the same kind of thing. We've got a -9 here, sorry, -9. So we'll add 9 to both sides. So we can cancel that -9 out. So we'll have negative 4x is less than -13 plus 9. So negative 4x is less than, that's going to be -4, isn't it? So now we're going to divide by a negative number, -4. Cancel out your -4. So x will be greater than 1. Like that. So then x is greater than 1, which is here. So I put an open circle because we're not including 1. And then draw your arrow in the right direction to positive infinity. So any number more than 1. In question E, it's a little more complicated because we have brackets, but when you see brackets, you need to try and get rid of those in most cases. Sometimes they can be factored out easily, but not this question. So let's multiply out. 4 times 1 is 4. 4 times -6, -24x is greater than or equal to 3x. And 3 times -5, -15. So we want to group the x's onto one side, and I normally put the x on the left side. So we'll have -24x minus 3x greater than -15, and subtract 4 from both sides, like that. So I'm basically just moving things around. So put your 3x on the other side, then change the sign, and then put your 4 on the other side and change the sign as well. So this will give you -27x is greater than or equal to -29. Sorry, -19. Like that. Let's write that again. So -27x is greater than or equal to -19. So now we need to divide by -27. Cancel your -27. And because you've done that, dividing by a negative number, change your sign around. So x is less than or equal to 19 on 27. So that number there is between 0 and 1. So we kind of estimate, and it's getting more towards the 1. So you can use a calculator if you want to get it exactly, but just mark that roughly where you think, and then draw your arrow to the -infinity direction. And then also mark that number on if it's not clear what it actually is. So that's 19 on 27. So do it like that. So in this next question, we have a fraction. And remember from semester 1, we always try to get rid of these denominators first. And you've got 5 and 8. So what number can you divide those into and then get a whole number? So if you think 40, we can try 40 because 5 times 8 is 40. So both of those numbers will be able to be divided into 40. So let's multiply both sides by 40, which is a positive number, which means we don't need to change the sign, okay, because we're multiplying by a positive number. So let's do some cancelling here. So 5 into 40 is 8, and 8 into 40 is 5. So now we're going to have 2 times 8, which is 16, 3x plus 1, greater than or equal to 3 times 5, 15, x minus 1, like that. Now we just basically expand this. So 3 times 16 is going to be 48x. 1 times 16 is 16, greater than or equal to 15x and minus 15. Now we'll group our x's onto the left side. So 48x minus 15x is greater than or equal to minus 15 minus 16. So basically, again, just move things around. So put your 16 on the other side and put your 15 on the other side and change the signs. So 48 minus 15, that's going to be 33. X is greater than or equal to minus 31. Okay, so now you've got a bit of an ugly fraction to deal with, but not a real problem. So then just divide both sides by 33. Like that, cancel your 33. So X will be greater than or equal to minus 31 on 33, which is a little bit less than minus 1. So that's around almost minus 1, but not quite. So mark that on your line. And because it's not very clear what the number is, you can write it in. Minus 31 on 33 there. Another kind of question you're going to get, and it's talking about integers. So we should talk about what an integer is if you forgot. Integers are whole numbers, which can be negative or positive or 0. So on your number line, those are the ones that show up here. These are your integers. They are whole numbers. There's no decimals involved with these, okay? So keep that in mind when we finish the question at the end. So we want to find the greatest integer, x, that satisfies this inequality. So any kind of question like this, you're going to need to simplify this inequality here. So do that first, and then we can answer the question. So let's write it again. So minus 3x, or negative 3x plus 2, is greater than or equal to negative x minus 4 plus 7. So let's see how we can simplify this. We have a bracket, so let's get rid of that. So minus 3x plus 2, that's okay, can stay for now. So minus sign times x, so that's negative x. Negative negative is going to be plus 4 plus 7. So let's tidy that up. So minus 3x plus 2 is greater than or equal to minus x plus 11. So let's group our x's together. So minus 3x plus x is greater than or equal to 11 minus 2. Okay, so we're going to get minus 2x is greater than or equal to 9. And now we'll get our x by dividing by negative 2 both sides. Cancel your negative 2. And remember to change the direction. So x is going to be less than or equal to minus 4.5. So you get some marks if you get that far, but you actually haven't answered the question yet. So let's think about that on a number line. So we've got, let's do minus 4, minus 3, minus 2, minus 1, 0, 1, 2, minus 5, minus 6. So this is any number less than or equal to minus 4.5. So minus 4.5 is here. Okay, just to be clear, that's minus 4.5. And look at the question. It wants the largest integer that will satisfy this equation here. And remember, these are the integers. These whole numbers here, these are the integers. So what is the largest integer that lies along this red line here? So minus 6 is less than minus 5. So the largest integer must be negative 5. Okay, so the largest integer is less than, or the largest integer is negative 5. That's the answer there. So any question like this, you will draw your number line. It will help you answer the question. And then find your integers, which are the numbers in green there. And negative 5 is the largest integer, which will satisfy this equation.